Hello students, welcome to my new video. Chapter 10, Light Reflections and Refractions of Light. As we know, the light, we know that the light is the form of the energy which help us to see objects. And because of the light only we are able to see the things, whatever in our surroundings. So when the light falls on an object, it reflected the light, and when the reflected light reaches our eyes, then we are able to see the objects. And the properties of light which travel in a straight line is called as the rectilinear propagation of light. Light always travel in straight lines and in the form of the bundles of lights. The common phenomena of light are formation of shadows, formations of images by the mirrors, and the lens, bending of light by the medium, twinkling of star, formations of the rainbows, etc. So see here, this is the reflections of light only. This is the refraction. That's why you see the pencils, that is the bendings, and the formation of the rainbow and splitting of the white light into the 7 colors called as the beam by a prisms. Now let us discuss about reflections of light. The reflections of light is nothing that when light falls on a highly polished surface like a mirror, most of the lights get sent back into the same medium, and this process is called reflections of light. Laws of reflections of light. There are 2 laws of reflections of light. The first law, the angle of incidence is always equal to the angle of reflection. This is the incident ray, this is the reflected ray, and this is normal lines. And angles between the incident ray and the normal line is called as the angle of incidence, and angle between the normal line and the reflected ray is called as the angle of reflections. It is always equals. And the second laws, the incident ray, the reflected ray, and the normal to the mirror at a point of incidence or lies in the same plane. So all these incident, reflected, and the normal, here they are in the same planes only. So types of the reflections. So there are 2 types of reflections. The first one is regular reflections. Those reflections which takes place on a highly polished surface is called irregular reflections. And due to the regular refractions, here the image is formed. And example, like say reflections takes place in the plane mirror, this is the regular refractions only. So images are formed due to the regular refractions. And another type is irregular refractions, and those reflections which takes place on the rough surface is called irregular reflections. Like that is the reflections occur in the where that is in the rough surface, like our wall. Our image cannot be formed, and due to these irregular reflections, the image is not formed, and if formed, the image is blur. That means not clear. You see reflections of light, rays of light enter and they reflect in different angle, and also the reflected rays of light, they intersect at different positions or in different area. Okay, so let us discuss about image formed by a plane mirror. As we know, the mirror, we used to see every day the mirror, and we never thought of how our image is at all. So let us learn today the image formed by a plane mirror. The image is virtual and erect. The image formed by intersecting the imaginary rays of light are called as virtual images. An image formed in our plane mirror is virtual image that cannot be formed on the screen. Second point is the image is same size as that of the object, but third, image is at the same distance from the mirror as the object is in front of it. That is, these image distance and object distance are almost same at all. So this is the third point, and number 4 point is the image is laterally inverted. That means our image, the left hands look like right in the mirror and all. So these are laterally inverted, and right it will appear as the left in our mirror. I mean that in the plane mirror. So this is what laterally inverted. Spherical mirror. Now, spherical mirror is a curved mirror which is a part of the hollow sphere of glass. Spherical mirror are of two types. There are concave mirror and convex mirror. Concave mirror. Okay, a concave mirror is a spherical mirror whose reflecting surface is inside a curve. And here this is the inside a curve. The curve here it is the reflecting surface. The pale rays of light, okay, coming parallel with the principal axis, up the reflections, they will converge at a point on principal axis. So the concave mirror are called as converging mirrors. Okay, and for the convex, the reflecting surface is outside the curve. Okay, and here rays of light pair with the principal axis. Up the reflections, okay, they will get diverse and appear to diverge from principal focus. So these convex mirror are called as the diverging mirror. See that it appears to diverge from the focus. So they are called as the diverging mirror only. Okay, now comes to the term used in the study of the spherical mirror. First is center of curvature. Center of curvature is the center of the sphere in which the mirror is formed and is denoted by C. Second point, the radius of curvature is the distance between the center of curvature and the pole of the spherical mirror. And number third is the pole, that is the center of the spherical mirror. And principal axis. Principal axis is the straight line passing through the center of curvature and the pole. Principal focus. In a concave mirror, ray of light parallel with the principal axis of the reflections meet at a point on the principal axis, and that is called as the principal focus. And in a convex mirror, rays of light parallel with the principal axis of the reflections diverge and appear to diverge from the point on the principal axis behind the mirror, is called as the principal focus, and is denoted by F. Now comes to the focal length. Is the distance between the pole and the principal focus, and is denoted by small f. In a spherical mirror, radius of curvature is twice the focal length. That means pole to focus, focus to curvature is equal. So R is equal to twice time of focus, or also F is equal to R by 2. Here we must take care about this one while drawing the ray diagram also, that pole to focus and focus to curvature are equal. So here the C is nothing, that is center of the curvature, and P is the pole of the mirror, and F is the principal focus of the mirror. And here distance between C and P is called as the radius of curvature, and the XY, that is the principal axis, and the PF is the focal length of the mirror. Reflections by spherical mirror. Rules to draw the ray diagrams is the one of the most important things. In a concave mirror, a ray of light parallel with the principal axis of the reflections passes through the focus. You can see this is a ray of light of the reflection pass through the focus. Yeah. And in a convex mirror, ray of light parallel with the principal axis appear to diverge from the focus. It get reflected, it got diverges, but appear to diverge from the F. Second rules. In a concave mirror, a ray of light passing through the focus. Up the reflections, it will go parallel with the principal axis. So this ray goes parallel with, and in a convex mirror, ray of light directly toward the focus. Up the reflections, it also go parallel with the principal axis. And rule number 3, in a concave mirror, a ray of light passing through the center of curvature, after reflection it reflected back along the same path. So this ray passing through goes reflected back along the same path. And in a concave mirror, okay, light directed toward the center of curvature, okay, after reflection it reflected back along the same directions. Number 4. In a concave or a convex mirror, a ray of light directly oblique, that is, falls on the pole, is reflected obliquely, making the equal angles with the principal axis. See, this is a reflected rays, this is an incidence ray, and this is reflected in case of the convex, and this angle of incidence is equal to reflections, and here in both case, the angle of incidence is always equal to angle of the reflections.